Good morning, all. How are you? Hope everything is going good. Okay, let's continue doing chapter number 2. We talked before about the levels, the three NC Spark or the NC Spark 3 level architecture of the database. And we said it includes the external level, which is the user views or user subschema or schemas. All right, and then the conceptual level, then the internal level, which represent the database physically. All right, as a recap, we have discussed the three levels, and we said these three levels, as you can see in this figure, represent the three levels: external level, including user views; conceptual level, including the conceptual schema; and the internal level, including the internal schema, which interacts directly with the database and provides physical data organization. Okay, we mentioned why we have this represented in three levels, why we separate the views. All right, we gave some reasons, and we discussed or defined each level. All right, so the external level is the user views or user subschemas. The conceptual level is the community view, which represent the data logically and provide logical structure. And the internal level will be, this is a conceptual and providing or defining all the entities, relationships, attributes, and any constraints. While the internal level will represent the database structure physically and anything related to the physical storage data, right, for storage space utilization. All right, and we stopped here, right? We said the physical level will be represented in the internal schema and the database, which will implement or which will be implemented and stored on the database. Okay, now we will discuss the schema, mapping, and instances. Having three levels will require mapping between these levels in order to make sure that every level will correspond with the other level. Okay, for example, if we have the external level or the user views, all right, we need to reflect whatever describe or define the conceptual level. Same with the conceptual level, we need to make sure that in the conceptual level it will be corresponding with the data structure, the data files or data definitions in the internal level. And as we mentioned before, that the conceptual level is ensuring mapping between the external and internal level, right? Now you know that the data structure of the database or description of the database means the database schema. Okay, this is a very important definition. Database schema means overall description of database of the database. This is the definition of the database schema. Okay, and we have different types of schemas based on the three levels. We mentioned this previously at the end of the previous lecture. We said the external schema or subschemas correspond to different views. It depends on number of views in the external level or user view. So each user will have a subschema. All right. Conceptual schema will also describe, same, it will be corresponding with the conceptual schema, describing any entities, attributes, relationship, and integrity constraint, while the internal schema corresponds with the internal level, which contain the definitions, store records, methods, indexes, store structures. Okay, there is there is only one conceptual schema and one internal schema. While how many external schema and a database might have? Anyone can tell? As I said here, there are only one conceptual schema and one internal schema. All right, only one. While in the external level, there might be more than one subschemas. Why? For what reason? Yes, anyone can tell the reason? If we have exactly, Qasim, thank you so much. So it depends on the user views, right? So if we have, for example, 3 user views, then we will have how many schema sub-schemas we will have for the external schema? We will have 3 sub-schemas. So it depends on the user views, all right? But the community view or the conceptual schema will be one only, and the internal schema will be one only. Okay, so um, this is very important. All right, so uh, don't mix it with other or external schemas. For example, if I give you an example, sorry, if I give you a question in the test as an example, you can say, I might say, if it is true or false, the conceptual schema has or consists of more than one schemas. Is that true or false? The conceptual schema or the internal schema consists of more than one schemas. It's false. Correct. It's false. Why? Because it's only one for the database, for the internal and the conceptual, for and one internal schema. Alternatively, if we said external schema, it consists of more than one subschemas, this is true, right? This is true. So just focus on this. All right, the database will ensure mapping between these 3 schemas. So, for example, checking the consistency and reliability of the data and between these 3 levels or these 3 schemas. For example, if we talk about the external schema, okay, we can say that it's derivable sorry, from the conceptual schema. So anything in the external schema will be derived from the conceptual schema, and it will be used to map it to map any information or details described in the conceptual schema will be used to map between the external schema and the internal schema. Okay, so if we say here, for example, can draw it this way. And I don't have a space here, but let me just draw it like this. This is the external level, or this is, okay, this is the conceptual, and we have here number of subschemas for external, and under this we have internal, and this is the database. There must be shapes here. This is the database, okay? Let's assume that this is the database. So how the mapping will be ensured by the database management system? It will be like anything in the external level. This is the external subschema. All right, I'll make it in red. So here the external subschemas will be derived from whatever there in the conceptual schema. For example, I can give you an example here, conceptual. I'm talking about schemas, okay? So external subschemas, conceptual schema, and the internal schema, because we are providing description of database, description of external subschemas, description of conceptual schema, and description of internal schema. Okay, internal schema. So any description here will be mapped, or any information or data available in each schema will be mapped with other schemas. For example, if we have, I mentioned this before, if we have here in one user view, we have age, we have name, we have many attributes, but it's not, I mentioned this before, right? It's not existed as it is, but it's derived from something in the conceptual schema called, who can guess, from which piece of information we derive the age? Anyone? The age can be calculated by having what? Yes, guys. Are you with me? Yes, user data. Which data? Which specific data that can be can be calculated, okay, to get the age? Yes, Qasim. Yes. So it's date of birth, right? Date of birth is available here in the conceptual schema. Okay. Date of birth field, for example, is available in the conceptual schema, and age will be derived from this data. Okay, so this is the meaning of anything in the external subschemas will be reflecting whatever described in the conceptual schema, or calculated or derived. All right, so it will be derived, and whatever there, it will be mapped with the physical representation which is described in the internal schema. Exactly. This is something, it depends on the user requirement, Qasim. So it's not something we can say it is existed in every user view. No, it's not, because it depends. If it's required to have it, then it will be displayed. Otherwise, it's not displayed. Okay, it's just an example. Anyway, the date of birth here will be reflected. Oh, okay, sorry, will be reflecting whatever described physically. Physically, for example, how many bytes uh, it will require in the internal schema, or the physical, or the storage space. So this is will be described here in the internal schema, but reflected in the age here in the external, and using the conceptual schema to map between them. So age in the external subschema will be described, okay, calculated and derived from the date of birth, and this is mapped with whatever described in the internal. Get the point? This is how the database management system managed to map between these three schemas, all right, or these three levels. Now we have two types of mapping. All right, maybe you understood, or you have this idea now in your mind about it. If it is between the conceptual and internal, it will be called conceptual internal mapping. Okay, it will correspond, whatever in the conceptual level will be corresponding with the internal level. All right. So it will find the actual combination in the storage or in the physical storage, and it will represent it as a logical record in the conceptual schema. So mapping, the database management system is able to perform mapping between the conceptual and internal level or schemas, between conceptual and internal schema, which will ensure, okay, having or finding the exact record that is corresponding with the, for example, physical utilization or storage utilization of the record, and it will represent it as a logical record. So physical record will be represented as a logical record in the conceptual internal mapping. Got the point? This is the thing that is performed by the database management system. I'm just removing this. Okay, so it will be managed and controlled by the database management system. It will be enforced on operations for the logical records. On the other hand, there will be external conceptual mapping. This is number 2, okay, which will make sure that anything in the external subschemas will be or will reflect the logical schema or the logical records in the conceptual schema. All right. So these are 2 types of mapping. Maintained by which part of the database? It's maintained by the database management system. All right. So it will allow any differences in entity names. It doesn't necessary to have same entity name or same attributes. Let's say same attributes in both levels. It's enough to just map it with it, and then it will work properly. Okay, if it is mapped appropriately, then there will be no problem of having different attributes name. Same with the entity name. Even attribute order, it will allow any difference in that. So it's not necessary to have, let me just go back here. Here, if we have in the external subschemas, if we have, for example, your ID number, okay, if it is starting with your ID number here in the student, for example, user subschema, you will or this subschema will include, or the user view will include the ID number for your name, your email, your major, right? These are attributes. So it doesn't necessary to be in the same order in both external or conceptual. It might be different. Okay, and this is allowed. This is allowed by the database management system. There will be no problem because there is a mapping. There is a mapping process between the external and conceptual. Okay, so attribute names might differ, attribute orders, data types, everything can be resolved after mapping. Okay, so it's related to each other and enable it to map the names. If it is different, it will be mapped. Okay, it will be corresponding with whatever stored logically in the conceptual level. Let's see an example here. This is a good example actually of mapping between these 3 levels or schemas. Can you see in the external view how many subschemas we have? How many user view external level we have? Yes? I'm just making sure that you are with me. Yes, Qasim. We have 2. All right, excellent. So we have 2 external views. you can see that every user view will include number of attributes. For example, this is the first one, serial number, first name, last name, age, and salary, right? So how many attributes for the external view number one? These are 5, right? For the external view number 2, we have 3, including staff number, last name, and branch number. So these are 2 external views. It depends on the user requirements. Now, there are 2 external views which will be merged in the conceptual level into one conceptual view. Okay, this is the meaning of one conceptual schema. All right, and these are different or multiple subschemas. But in the conceptual level and internal level, it must be one view or one schema. So as we said, as we mentioned, the age here will be derived. See, this is what I meant by having a derived attribute based on an existing attribute in the conceptual level. So derived in the external level can be calculated based on an existing attribute or existing record, let's say. So it has been changed into date of birth here. Why? Because the mapping between them will be maintained. Even if we don't have date of birth here, alternatively we have age, but it means that it's mapped with it. Okay, it's mapped. The database management system ensure mapping between them. Let's see how this data will be represented internally. See, this is the meaning of physical representation. So in the internal level, the structure will be staff. Okay, so the whole schema will be called staff, and it will be including or consisting of integer. See here, what is the type of data? This is defined in the internal schema. So integer staff number, which means that staff number will be a number, right? An integer number. Integer, a branch number. Car, first name, how many characters? 15. Okay, so it's specified the size of or the length of the word or name entered will be specified here internally. Same with the next one, the last name, 15 characters, the structure, date of birth. So this is date. It will be formatted as date. So um, basically, it will be defining all the data structure, the data definition, the data type, all right? And sometimes the index, it will be also mentioned here. Float for the salary, structure staff. Next, what's the next point to the next staff record? These are some also processes considered or actions. Index staff number, index branch number, define indexes for staff. So this is an example of the internal schema mapped with the conceptual level. So here, how we can map these to this? It's exactly the same, but in different view, right? In different view. And the database management system will ensure mapping between these 3 levels. Got the point? Is it clear? How we can how we can understand how the database management system map or provide mapping between these schemas? External conceptual mapping, conceptual internal mapping. Okay, these two are, as we mentioned here, conceptual internal mapping and external conceptual mapping. So these are so this is number 1 mapping, and this is number 2. All right, so whatever there will be reflected in the external, whatever in the conceptual level will be reflected and in the external level. Whatever in the internal level will be reflected properly um, in the conceptual level as a logical record, and this will be maintained by the database management system. So two types of mapping. Got the point? Mapping. Okay. All right. Now here, for example, serial number field, sorry, not serial number, let's say staff number. Okay. In the first, it's called staff number. Can you notice that? Let's say the number here. But it's the same as staff number. So this is managed. It's allowed by the database management system. It doesn't matter that if we have in one external level one certain attribute with a different name. So it will be same mapped with the same. So both will be mapped with this, right? Staff number here and the staff number from this will be mapped with a staff number in the conceptual level, and also it will be mapped with integer staff number represented in the internal level. So it doesn't matter if we have different attributes name, it will be maintained or allowed and mapped. It will be resolved by the database management system. Same here. Some physical description will be provided and will be reflected in the conceptual level. And you can see here the definition of the structure in high-level language. Okay, so the structure of the data will be represented here, and it will be different from the conceptual level, but it will be mapped. And like also a pointer will be provided in this level. Pointer means like next. Okay, it allows more records of staff members or staff members to be linked physically as a chain. Like for example, next staff member, next staff member. So it's like a chain. So this will be allowed in the physical representation. No, yeah, no. It will be logically defined as one view. See, because why we can see different names here? Why we can see different names? Because we have different or number of subschemas. So different user views. So the name of attributes might differ, and it's allowed. It's okay. There is no problem. But when we talk about the conceptual level, it might be one community schema. Okay, and one community schema, it doesn't mean that we can have more than one name for every attribute, right? Awesome. You know what I mean? Get the point? So it will be only one schema providing only one set of attributes with the consistent names, of course, and mapped with whatever the external view and the internal view. Now you have a better understanding about the levels and how the data will be represented in each level, right? Okay. So it's important to understand the description of the data and the database itself, the database and the data. Okay, so for example, the description of the database means this schema, right? The database schema. So it's important to differentiate or distinguish between this description of database and the database itself. As we mentioned, the description of database is the database schema, or it's called intention. We call it intention. All right, and the database schema will be like described in the database design process, but the actual data may be changed frequently. Okay, the actual data is different, something else. Okay, the actual data might be changed. For example, it can be changed every time we insert details in the new member of staff. So a new member of staff can be added every time with new details, new data. So actual data can be changed. Okay, by time passing, we can see there are more records to be added. This is the meaning of database itself. It can be, um, for example, changed in terms of adding new records, new data. While the database schema or the database or the description of the database will be defined or specified in the database design, and it will be like, a consistent. It will be as a template. Let we say it's like a template that will be applied on the data itself. Okay, what we call any data, the data in the database at any particular point in time, for example, it will be called database instance or extension. So we said that the database schema is called what? Intention. Now you need to put these terms in your mind. Okay, the database schema is the description of the database, or we can call it intention. All right, intention. While any or the data which will be presented in the database, which will be stored in the database at any particular point, the data itself will be called what? Database instance or extension. Okay. Um, so many kind of data can correspond to the same database schema. So it can be corresponding to each other. Database schema and the data itself, it will be corresponding with each other. So got the point here? The database schema, which means the description of database, can be known as intention, while the data itself, okay, the data itself at any point in the database can be known as database instance or extension. Extension, as we mentioned, can be um, like, for example, changed, we can add more data, more records, all right? While the schema or the intention will be like a template or described in the design, in the process, the design process of the database. Okay. Now, this is something very important. We need to know that the main objective for the three-level architecture is to provide data independence. You remember when we talked about the advantages of database management system? Um, First, we discussed the file-based approach. You remember one of the limitation was data dependency. The data definition is embedded with the program code, right? With the application program code, which will make it very difficult and hard to maintain or to change or modify without affecting the program code. So, but in the database management system, it will be different because of the data independency. Data independence means that anything will be not reflected. For example, anything stored internally will not be reflected. Sorry, not reflected. Any change in the structure, for example, this will not affect. It will not affect the external views. So you will be not aware of whatever going, whatever modified, whatever change in the internal level. Okay, so this is the data independence. Yes, exactly. So only, as you said, awesome. uh, only we are aware of whatever is allowed to be represented in the external views. But whatever is updated or modified internally in the data structure or the logical reports, sorry, not reports, the logical records, this will be not affecting the lower, the upper level. So let's talk about it as two kinds of data independence. Logical data independence, this is number one, and physical data independence. And we will talk about them. What does it mean? What does it mean by saying logical data independence or physical data independence? So um, here, as a summary, the data independence means upper levels are unaffected by lower levels. Okay, upper levels are unaffected by lower levels. So this is the main objective or major objective of the three level. Why we need to have three level? Because we don't need to, um, for example, allow any like let's say provide mapping, or we don't need to make any upper level to be affected by any change in the lower level. Lower levels will be physical, and the conceptual will be logical. So this is between the conceptual and internal levels. So let's talk about them. So let's talk about logical data independence. Logical data independence, it's here we can define it as the immunity of the external to changes in the conceptual schemas or schema, sorry. The immunity of the external schemas to changes in the conceptual schema. So this is the definition of the logical data independence, which means that the external subschemas will not be affected, okay, by the changes in the conceptual schemas. So, for example, we are adding, removing, updating some attributes and entities and relationships. Okay, this is something can be performed in the conceptual level without changing anything in the external level. Got the point? So we don't have, for example, to change the program code or to do something like changing how the data will be represented in the external view. Just we are having updating or modifying something in the conceptual level without affecting the external schema. Now, for example, what if we need to have this change? Yes, the data itself is changed, but the user is not aware of it because it's not reflected. It's not shown. It's it's not. I cannot say it's not reflected. Any change must be reflected, but it's not seen. It's not. It's hidden. For example, it's hidden. Why a student, for example, need to know that the relationship between the courses and the academic member or staff member is changed. Okay, why the students need to be aware of that? It's not necessary, right? So this is the exact meaning of logical data independence. It ensures that whatever changed in the conceptual level will not affect the external level. But in one case, if the user need to know or need to have this change, it will be affected. Like, for example, mm, something added, something new added, a new record like address, as I mentioned before, address. It's added in the conceptual level. It must be there also, right? In some specific views, or each student will be able to see this field or this added field. Even the study study field, you notice that I noticed that there is a new field added or new attribute added to the student class list. So for example, my section class list for ITIS213 is displaying student ID, student name, major, in addition to study status. Is it physical or online? Got the point? So my view is affected in this case. Why? Because I need this information. I need to know. But whatever happening internally, like changing the data structure or changing the relationships or the attributes, okay, or number of characters, this is not affecting the external or how or the way I am perceiving data in the external level. Okay, so the logical data independence, the immunity of the external schemas, two changes in the conceptual schema. Or in other words, you can define it in different words. You can say it's anything or any change of data or data records or logical records in the conceptual level will not affect the external level. Okay, so this is also, I can write it here, any change in the conceptual schema will not affect the external schemas. All right, so this is another definition. We can define it this way. Same with the physical data independence. It's the same, but in this time it will be between conceptual and internal. The other direction, يعني. You remember the figure, the three levels, external, conceptual, and internal. So from upper levels will not be affected by changes in the lower levels. So upper levels, like an external user views, will not be affected with a change or two changes in the lower level, which are internal. Okay, so it's immunity or the immunity. Here we have the definition, the immunity of the conceptual schema to changes in the internal schema. Same way here, same idea. We can say also changes in the internal schema, okay, will not affect the conceptual schema. That's it. Okay, so this is how we can understand it. For example, we change the how the files are presented, or we change the storage structure, file organizations. We save it on another device. Yeah, exactly, Qasim. That is the point. We save it on another location, all right? Another device. We modify the index, the algorithms, or anything related to the physical representation changed will not affect whatever there in the conceptual schema. All right. So here we have some examples. If we change the organization, file organization, okay, or storage structure, storage structure, okay, or storage devices, anything changed, or indexes, or algorithms, anything changed will not affect the conceptual representation, okay, or the logical representation. Now, physical data independence, continuing talking about the physical data independence, the only effect noticed is a change in performance, okay, from the user viewpoint, from the user's point of view. Only change they can feel, they can see it, is the change in performance. Okay, performance of the entire database management system. Um, so, for example, deterioration in performance is the most common reason for internal schema changes. So, any change will cause this kind of changing in performance. Okay, now this figure illustrates where we can see the data independence, each data independence, it will appear in between. Okay, so for example, this is a very, it's like a very clear figure that illustrates where we can see the external, the types of mapping and the data independence at the same time. So if we can understand the external schemas, sub-schemas on the top level. Then comes the conceptual schema, and the lower level there is the internal schema. What comes in between? We have this mapping. We have two types of mapping: external conceptual mapping, which ensures that the the records or any data, the data description will be reflecting or mapped between these two levels. So whatever and the external schemas will be mapped with the conceptual schema, but there will be or the database management system will allow or resolve differences in attribute names, right? In, for example, attribute order and so on. Number two, the conceptual internal mapping. This will ensure that the records or logical records is corresponding with the physical records in the internal schema. So there will be mapping. So two types of mapping and two types of data independence. And logical data independence will appear between the external and conceptual schema. Okay, logical. And physical data independence will appear between conceptual and internal schema. And logical data independence means any change in the conceptual schema will not affect the external schema. Same with the physical data independence. Any change in the internal schema will not affect the conceptual schema. Get the point, guys? Is it clear? Okay. Uh, yes or no? All right. Now, it's like two stages or two-stage mapping. Okay. And here is they are saying that it might be inefficient. Okay, but it will provide data independence. So the two-stage mapping might be inefficient, not not going properly, but it will ensure great data independence. How about if we want for more efficient mapping? The ANSI Spark model allows the direct mapping of external schemas on the internal schema, bypassing the conceptual schema. Okay, so it will reduces data independence. So every time internal schema changes, the external schema and any dependent application may also have to change. All right, got the point here? So in order to have more efficient mapping, um, the model, the ANSI Spark, the 3 level, will allow the direct mapping between the external schemas and I'm sorry, just a minute. Okay, between the external schema directly to internal schema through the conceptual schema. All right. So this is just a minute. I'm sorry. Okay, just email. Oh, sorry. I'm sorry. I'm so sorry. Okay, so time is up already, but here it's just if the database management system needs more efficient mapping, it can be by direct mapping between the external and the internal, uh, without having it map with a conceptual schema. By so by passing the conceptual schema, not map it with conceptual schema, and this means that if the internal schema changes, the external might be changed as well. Okay, so this is something can be performed by the database management system or the data model of the three levels in order to ensure efficient mapping. So we stopped here. We are stopping here. The DML and DDL. We will next time we will discuss about these sub-languages or data sub-languages in more details. Do you have any questions? Let me just check the attendance. Okay. No questions, guys? All right. Okay, so thank you for attending today, guys. Take care of yourself. See you next time. And I would like to thank you also, Qasim, for interacting.
Good
Yes,
morning,
Abbas.
Doctor.
Yes, Abbas.
Yes,
Good
Doctor, I
morning.
have overlap in on my courses between ITIS213 and ITICS214 in the same time,
Okay.
same time of the lab in the database management system in this course.
Okay.
What can I
Yes,
do? I
with
contact
your
with Dr. Nawal Safar.
A. What
Oh,
did she say?
she said to me, I will see to registration, okay, and we will solve a new solution.
It will be resolved by allowing you to attend the other sections lab session, right?
Okay, but
Because
I think
two students.
I contact with the instructor of the lab instructor, okay.
Mm-hmm.
She said to me I have two section in this week, every week, but in the same time, 12 p.m.
Ah, okay.
Dr. Muna.
Okay, so yeah, wait, I think Nawal can resolve this because she's communicating with the registration, right? So she
Yeah,
can just put your name in another section another
yeah,
time. But you are saying that both sections are at the same time?
yeah. But
Mm,
Dr. Mona said she said to me, I have two sections in every week. One of
at the
them
same time.
on the Monday and on Sunday
Mm,
at 12
okay.
p.m.
Okay,
But
Abbas,
he
I will check, inshallah. Let me ask Nawal myself, and we will
okay
see how we can resolve this. Okay, I'll take your
okay
ID
okay
number.
Doctor, what do you prefer about what can I attend every day in the lab or in the lecture of other another course?
Uh, you mean you change the section?
Yeah,
It
yeah.
it depends on you. You can
But
decide,
in
Abbas.
this
You have
by the
to.
way by the way in this week or after uh, until when we see that solution, I join to section for the ITCS 214 or lab.
Mm-hmm. You have this
What do you
option.
prefer? What do you prefer?
Well, I can say that whatever suits your timetable, then go for it.
Mm-hmm.
Even if you want to change the section, I have no problem with that. But I think the only way this will be resolved is by changing the lab section. If there
Okay,
is a
doctor.
possibility to add you to another lab section, so it will be great. So
Okay.
your timetable will not be affected by this change, right?
If I have another question. Can the doctor
Yes.
make a recording? I see the recording after the lecture.
Yes.
But
Yes,
this
yes,
way,
sure.
this perfect way. I will show the recording.
Yeah, yeah, I can show you the way. You mean how I can see the recording?
Yeah,
Yeah, yeah, I will show you now.
I go to tools and Blackboard video, and I go
No, you
recording.
just
I click.
yeah.
Okay, doctor.
See, I will show you just to quickly. See,
Okay.
you see this the screen? When you go here, you go to the
Oh,
Blackboard Collaborate. You can go to the setting, view all recordings, and all recordings for the lab sessions, in addition to the lectures, will be listed here. For example, today's lecture is already. I didn't stop it yet, so it will be uploaded here. So I have renamed all these, so you can go to which chapter you prefer, for example. Okay?
okay, doctor. No problem. Thank you.
Okay. You're welcome, Abbas. Thank you.
Sorry. Sorry, I take your time.
That's no, it's okay. It's okay. No
Okay.
problem. Okay, thank you so much. Thank you.
Thank
See
you.
you next time, inshallah.
Thank
Take
you.
care. Bye bye.